everyone. It is like 9 on the dot. So I'm going to go ahead and get things started here, and we'll start our first presentation in just a moment. Just a couple of reminders. You have 10 minutes to present. There is this handy dandy little green, yellow, red light up here for the first 10 minutes. The light will remain green. Once you get past 10 minutes, it will go to yellow, and once it goes to red, that means that 13 minutes have passed and we need to have the 2 minutes for there to be changing back and forth. If something happens and someone doesn't show up for a talk, in order to maintain the integrity of the schedule, we will wait until the end of that talk to start a following talk. Already said it, but you have 10 minutes per presentation, 3 minutes for questions. If you go over the 10 minutes, that'll just cut into your question time. And I would like to make sure that we are thanking all of our Diamond sponsors for sponsoring this event. Definitely go out and check the sponsor tables and go get some cool swag and stickers. But without further ado, our first speaker is Suhan Lee, and it will be a recorded presentation that we'll show. And Suhan Lee is here on Zoom and will be available for questions at the end of the presentation. Before we do get started, are there any immediate burning questions? Excellent. Okay. Once again, thank you so much for coming. I really appreciate it. Oh, and I'm Kit. I don't know if I introduced myself. I'm Kit. Nice to meet all of you.
Good morning, everyone. It is a great honor to speak to you today on the topics of revolutionizing plant pathogens conservation, the past, present, and the futures of AI in preserving the natural ecosystem. I'm Suhan from Swinburne University and joined by my esteemed colleagues Pierre, Elliott, and Alexi from CIRAD and INRIA. Before we dive into AI approaches, it is important to understand the magnitudes of the problems we are addressing, which is the proportions of the world's plant species estimated to be at risk is increasing. These large scales of the plant extinctions pose a significant threat to the global food security, and the extinctions of the plant species can have a cascading effect, endangering their native pathogens as well. These pathogens, although often seen as harmful, they play significant roles in maintaining the ecological balance. Native plant pathogens are not just the agents of disease, they are integral components of our ecosystems. These microorganisms play crucial roles in natural and semi-natural plant communities, contributing to the complexity and the stability of the ecosystem. Hence, preserving these pathogens is crucial for the ecosystem health and agricultural innovation. In this presentation, we will delve into the significant role that AI plays in preserving our natural ecosystem, particularly focusing on the plant pathogens. To appreciate the advancement we have made, let's first look at the historical perspective of the plant pathogens conservation. Traditional methods rely heavily on the manual observations and the documentations. These traditional approaches were costly and time-consuming. These efforts, while invaluable, were limited by the human capacity and the availabilities of the resources. With the emergence of digital technologies and AI, we have transitioned to more sophisticated approaches that offer greater precision and efficiency. In the early days of AI application for plant pathogens detection, the focus was on classical machine learning algorithms. Researchers trained these algorithms on image datasets, teaching them to differentiate between the healthy and the unhealthy samples. However, these early systems were limited by the challenge of finding the right features to represent the disease symptoms. Then came the breakthrough with deep learning. Unlike traditional machine learning methods, deep learning models don't rely on the manual feature extraction. Instead, they handle both feature extractions and classification in a single unified process. Convolutional neural networks, for example, is widely deployed due to it has had several notable success in the large-scale image recognition challenges. Recently, a new revolution in neural network has emerged. We call the vision transformers, the VIT. These models are showing performance that is comparable to, and in some cases even surpasses the traditional convolutional neural networks. Here, we compare the concepts of CNN and the VITs. CNN rely on local receptive fields to detect the repetitive features across the images. However, this approach can be limited because it only captures short-range relationship within the receptive fields. In contrast, the vision transformers excel at capturing the long-range features through their self-attention mechanism. This is important in plant research, where disease characteristics might be spread across the various plant organs or across different regions within the plant organs. To examine the features learned in each model, we use the GradCamp. In our research, we observed that although CNN and VIT may achieve comparable performance, they focus on different aspects of an image. For example, for CNN, the heat maps typically highlights the local features and the short-range details. For example, the leaf venations, the blade textures, or contours reflecting the leaf shape. This focus helps in capturing specific detailed features of the plant itself. On the other hand, VIT captures long-range relationship across the entire image. It can track the plant disease symptoms which are distributed over a larger area, offering a broader and more integrated views of the plant's condition. Despite many advancements, AI still faces challenges in becoming truly sustainable. To meet practical needs, AI system needs to adapt to different scenarios and handle new cases effectively. Here are some challenges in achieving sustainable AI technologies that are closer to practical needs. Let's explore the data distribution skill challenges. It is often not feasible to collect all the data in the world, especially plant disease data that is not always available. With minimal numbers of data, misalignment between the source and the target data distributions tends to occur. To tackle this challenge, our research team is actively exploring novel methods to improve the model's adaptability and generalizations across different data distributions. For example, in our early studies, we developed a symptom-oriented feature learning approach. So this method, it trains the models to focus on disease-specific features by leveraging the data from different crops with the common symptoms. We also tested sequential models such as RNN-based approaches using the gated recurrent units to learn disease features across different regions of plants. And recently, our research teams explored leveraging disease features extracted from herbarium specimens. These specimens often contain key characteristics essential for identifying various plant diseases, making them valuable resources for our research. Aside from addressing data distribution skill, our research team is also exploring methodologies that integrates the human perceptions into the AI system. As without this expert guidance, machine might end up learning irrelevant features that do not pertain to the plant diseases. In response, we propose a new deep learning model called the conditional multitask learning methods for plant disease identification. So unlike the previous models that focus solely on the symptom-oriented features, this approach integrates the expert knowledge by incorporating prior information about the plant species. But the model still faces limitations when encountering entirely new classes. This highlights the need for the further motivations to address the challenge of out-of-distribution data. So what is out-of-distribution data? This issue arises when a model encounters data that falls outside the distribution it was trained on, particularly with new or unseen classes. For instance, in our dataset collections among our seen classes, we have examples like tomato late blights, tomato leaf mold, peach bacterial spot, but our unseen class, which is the tomato bacterial spot, has not encountered by the model during training. Our recent proposed methods, named the FFVID model, it uses an innovative feature embedding learning methodologies. It first maps and disentangle the image into the host, species, and disease features, then combine them to generate synthetical embedding for both seen and unseen classes. However, new classes that are not represented in the existing training set continue to pose a challenge. Disease identification in plants often requires more than just analyzing images of plant organs. For example, experts also take into account environmental data, neighboring disease occurrences, and other relevant information. Hence, looking ahead, One of the most promising directions to drive the futures of AI in plant pathogen conservation is the development of advanced AI models that can integrate a variety of data sources to provide a more complete understanding of plant disease dynamics. Plant disease epidemiology surveillance involves the collections and analysis of data across various taxonomic and geographic scales to monitor plant diseases. However, this surveillance faces significant challenges. For example, data availability often restricts the ability to make accurate predictions. Integrating diverse factors influencing the disease's dynamics is also complex, and validating the predictive models against the real-world data can be difficult. To overcome these challenges, the concept of the digital twin in plant disease epidemiology surveillance becomes incredibly valuable. A digital twin is a dynamic virtual model that mirrors real-world ecosystem, including plant health and disease pattern. This technology offers significant advantages. It enhances our ability to monitor and understand changes in plant health and biodiversity. As with this digital twin, we can predict disease outbreaks more accurately and evaluate different control strategies through the scenario simulation. To enable large-scale pathogens monitoring and conservation, integrating information from passive surveillance networks such as the citizen science platform, where people contribute observation from around the world, is important. The projects we have launched, the Plant Agro Eco, is a crowdsourcing platform designed to revolutionize plant pathogen monitoring and conservation. By incorporating a wide range of environmental data, Plant Agro Eco enhances the model's ability to make accurate spatial predictions. This integration allows us to create a more precise, dynamic digital twins of natural ecosystem, significantly improving our capability to monitor and manage plant pathogens on a larger scale. In conclusion, by harnessing the power of AI, we can enhance our abilities to monitor, predict, and manage plant diseases, ultimately contributing to the preservation of our natural ecosystem. However, it is important to recognize that AI is just one part of the solution. Ongoing research, collaboration, and investment in this field are important for realizing the full potentials of AI in conservation. Thank you very much for your attention, and here I end my presentations.
We have a couple of minutes for questions, about 2 minutes. So if anybody has a question in the room, feel free to come up to the microphones or raise your hand. And if anybody has one online, feel free to put it in the Zoom chat. Okay. So if we don't have any more questions, I'm going to wait about a minute to move on. So if you do think of one, feel free to put it in the chat or come up. But we will wait about a minute before we have the next presenter up here. Okay, there's one in the Zoom. Okay. Do you want me to bring a microphone to you?
The question in the chat from Gail is, has this been tested with plant virus diseases where the symptoms may be more subtle?
Hello, can you hear me?
Yes, we can hear you.
Yeah, so for all of our experiments, we are using the SYM benchmark, for example, the plant village dataset. So it covers the bacteria and I believe also covers some of the virus diseases. So we use the SYM benchmark to test our models. So in our next work, we will integrate more different kind of varieties of the diseases into our experiments. So we are currently trying to collect more data from, let's say, the research papers, others new published data sets. And we also try to using the field data that we're going to collect also on the site.
Awesome. Thank you so much. And thank you for answering that question. We are going to move on to our next presentation. So our next presentation, if you're in Tadwig, you have seen this name many times, is Patricia Mergen. And she will come up and talk a little bit more about that. Thank you.
Okay. So good morning, everyone. So my presentation will not be directly on a specific EA application, but it's more like a reflection on the environmental impact of the increase of much use of digital technology and artificial intelligence nowadays. Oops. That's not making... is there an environmental impact of digital technologies? So being in the post-COVID time, we hear many voices saying, during COVID, it all worked digital. So why not continue like this and reduce our impact on the environment that we know because of flying? While on the other hand, you have both for private or professional reasons, this so-called revenge travel, where people increasingly start to travel massively again because they couldn't for so long and they really missed it, bringing risk to again increase the environmental impact of a lot of travels using planes and other means. But is this really so? So while the annual CO2 emissions for travels and other transport emissions are still much higher than those of the digital use. And you can here see the projection of what some call the wishful thinking of the reduction of CO2 emissions for the future. But you can see in this little red line that the CO2 emission linked to the use of ICT is gradually increasing. And in a study of 2021, up to 6% per year and continuing to grow. And it will still, if the protection stay like it is, go to the same level as other emissions. The study done by colleagues from Green IT in France in 2019 showed that actually the biggest impact comes from the massive use of user equipment in all the categories, being it energy, greenhouse gas effects, water, electricity, or disposal of waste. And also the projections onto 2025 showed that the biggest increase is with the users and the devices, rather with the networks or the big data centers that are built, that have also an impact, but is lesser than how we users act and use multiple devices. Also, besides the impact on emissions, there is also the raw material used for our smartphones and devices. You can go look at this website, which has a quite nice animation to show how what elements are used for the different components of your smartphone, and they also give information where they come from and what the impact is. You can see, for example, a very big cobalt and copper mine in Congo, provided by Amnesty International, which can show you the impact on the nearby towns and villages. The group Data for Good made an analysis in 23 showing that the usage of ChatGPT 3 emitted already 10,113 equivalent of millions of tons, and they estimated at that time already that moving to ChatGPT, it can increase by 10 or even 100-fold this CO2 emissions. And IE is present more and more in our daily life, not only research, but also for policy making or for simple entertainment. And they also made estimation about the increase of electricity use, where EI use will also ever take a bigger part. So does it mean that we should all give up now on IT and IE development and go out of the digital age that we are now? So probably not. So those making studies about that took a bit the example like what we do with climate change, that there can be outbalancing and mitigations methods depending on what are the purpose of EA, and if EA can really improve the conditions, reduce other environmental impact and make our life better, like the examples I should show here for better planning, of course, things like e-naturalis to identify more species, things that can give health support, better research, help people with handicaps, robotics can outbalance. But if EA is used to rank or manipulate population or elections, or used for pure advertisement or entertainment, we can think a bit, should we really use it that massively or not, knowing the impact it has on our environment? Sustainable IT and IA, is this possible? What can we do? So there are already known methods, like professionally and privately. Do we always need the last model? Don't throw away your old phones, give them a second life, or keep them or upgrade them. It's not that easy to find on the market, but there are more and more so-called fair digital devices where they pay attention that the components they are made of don't exploit the local population or have a lesser environmental impact. You can also change your behavior, only use audio when video is not needed, avoid multiple attachments that some people might not even open or read. Also, many people have now these fancy signatures in their emails, and even this image's signature, which doesn't seem a lot, increases a lot the usage. And sometimes just put your name in text, even if it's less fancy, it has already a huge effect if you compare the very high traffic of emails. And there are also recommendations for your websites and portal device and the way they are configured and used, that they can be with lesser resources used, like shown. So I was made aware of this sustainable IT by the Institution of Sustainable IT that have already branches in France, in Belgium and Switzerland. So I was happy to follow a whole evening workshop with them. That was much longer presentation that I can share with you that showed all these possible impacts and what to do. They would very be happy to extend that network of institutions within Europe and beyond. So if you are interested, go to their website and say, yes, my country would also like to have something like that. In most of the European projects, they now put forward the so-called green IT, and also for all the research infrastructures like DISCO and others you will hear, they also very much push that we pay attention, hence our scope with biodiversity and conservation, that we should be the model to use more green IT for others that use IT and that maybe not so much in the environmental topic. If you go to the associations of sustainable IT, you can already sign charters where you simply commit to follow some better practices. And if you will really go further, you can have a sustainable IT label where you really show that you do something, and they come check with there is a lower and higher level how far you want to go, and they can really check regularly if you really comply and if you can keep your green IT label or not. So to finish, I would like to thank all the different projects I've been involved, where it was not a specific task, but I could discuss a lot with them about sustainable IT and get more ideas. And I hope this can continue. And certainly also the Institute of Sustainable IT, who was really helpful to prepare this presentation. Thank you very much.
There's a question in the chat on Zoom from Gail. How much would using renewable resources, e.g. solar or wind, have a real effect on sustainability?
Huh, that's a great question. I would say the studies have not been done. So I looked up for references, and there's still a lot of studies, I think, to do to be able to answer with more certainty to such a question and give figures. But certainly some of the graphs I showed before show that you can reduce this percentage of increase of impact. Personally, I'm a bit doubtful seeing the increase of IT use, that even by making this awareness, I don't think it will reduce that much, even with the outbalancing or mitigation effect, unfortunately, because I don't think we can stop the industry or other more technical application to go forward with the connected devices and so on. If that can answer the question, but I don't have specific figures, unfortunately, to give at this stage.
We have time for like one more question.
I guess I'm always struck in presentations like this, the kind of disparity between, so we have NVIDIA, huge company, shares rocketing, OpenAI, huge things, and these little personal acts that you're kind of talking about. It seems the scale of impact of those is minuscule compared to those sorts of things. Recently, Meta is now getting into geothermal energy to power data centers. So I guess my question is it realistic to expect reducing the size of my admittedly quite large email signature is going to make a dent in this kind of world?
Well, according to the colleague from the Institute, he said we think individually that it's not much, but if you take the millions and billions of mails that are sent around, and also knowing that when you forward your email, the image of your signature can show up like 10 times if you go back and forth, it can have globally a big effect. So it's a bit the same thing when you say, if I just throw a small thing of plastic, it will have not much effect on the sea. But if you look at the whole planet scale, it certainly has an effect. So every little single thing you can do individually, if a lot of people are doing and get aware, it can certainly have an effect. Even if just 2 of us do it, then not, of course, you can't measure it, but at the scale of the planet, I think it can have an effect.
So we'll have to wait on questions. There are a couple more in the chat, and we'll make sure to get those over to Patricia. So also, thank you so much. That was wonderful. Okay, so our next speaker is Michael Elliott from the Florida Museum. He's also our reigning student champion from last year. So big warm welcome to Michael.
You shouldn't set the expectations so high. Okay, so I'm Michael, and my talk is titled Integrating LLMs in the iDigBio portal for conversational data exploration and inference. And this is a mouthful, but what it boils down to is we're experimenting with developing chatbots that can help us access and navigate iDigBio data in ways that are a little bit more just beyond what we can currently do with existing interfaces. So the iDigBio portal, most of you are probably familiar, but it serves millions and millions of records that are made available from different institutions, mostly across the United States. They have over 140 million specimen records and 57 million or so media records. And there are two main ways to get at this data. So it's the data I'm looking at is mostly occurrence data, so saying where species are. And the first main way, the most user-friendly way, is to use this search records interface. And what it allows you to do is specify the types of records you're looking for. So for example, you can put a scientific name or a country in there, and this interface will spit out a list of records that match your criteria, and it'll show them on a map. Now, the second way to access data through the portal is through the APIs. And there's a bunch of different APIs. There's a search API, a download API, summary, all these different APIs. And the thing that you need to know about APIs is that the P stands for programming. So they're not made for people. They're made for software machines to use. So they're not so readily accessible by humans. So there's all of this data locked behind these APIs. And the search records interface actually is built on these APIs. That's where it gets its information, but it's serving a very specific purpose. So this search API in the interface is very user-friendly. It's a nice graphical interface, but it's very specific. It only does one thing. It searches for records, and it shows them on a map. Whereas the APIs are very flexible, but they're very hard to use. They can access everything that iDigBio has from multiple different perspectives, give you different types of data, but it's targeted toward programmers and machines. So no graphical interface, no website. Now, if we wanted to make use of all the information behind these APIs, we would either have to make one really big interface that can do everything and would be really confusing, or make a bunch of little interfaces like the search one that we have right now. But both these solutions are kind of not ideal because first of all, it'd be confusing to have so many different features for one iDigBio portal with potentially overlapping capabilities. It'd be a lot of work to create all of these things, and it can be very hard to maintain that many different services. So what we're wondering is maybe with the rise of chatbots like ChatGPT and that are powered by LLMs like GPT or Google Gemini or all these different LLMs, Llama, they're very adaptive. So they can, because they're conversational, or they're creating these conversational systems, all you have to do is be able to express what you want in natural language, and they can potentially get it for you or help you point you in the right direction. So that's very user-friendly. If you can speak, if you can type, you can use these things. And it's very flexible. If you can put something in words, it can potentially answer it. Might not be the right answer, but it'll be an answer. So if we can leverage both of these things, it's kind of the best of both worlds, user friendliness and flexibility. So I went ahead and I asked ChatGPT, please generate a call to iDigBio's records API to find species occurrences in Okinawa, Japan. And it spat out a really long response, but I took the snippet. Specifically, what we're interested in is this URL that it generated at the bottom, that HTTPS, blah, blah, blah. Now, the first half of that says that it's pointing toward the iDigBio API, so you would use these kinds of URLs to interact with the iDigBio data. And obviously, like most people don't want to be writing out URLs. It's just not a nice way to use things, and and then the right side of the URL has these search parameters that describe the user's request. So we see the country, Japan, the county, Okinawa. There's a couple of problems with this URL that it generated, though. The first one, that api.idigbio.org, that's not actually the right website. So this thing is useless. The second problem is that it chose county for the field name for Okinawa, and that's not really optimal. There's only a few records that do that, but most of them use like a state or a province field instead of the county one. So this isn't a very usable experience so far. So our chatbots salvageable, even though they have this unpredictable performance, so they make mistakes, even though they're friendly, user-friendly and flexible. So what we're looking into is how can we make them more robust, more reliable, and give better outputs. So the approach that we have tried to implement, or maybe successfully implemented, we'll see at the end, is through using what we call agents and validators. So the agents are LLMs that are implemented in a very specific way. So they're for designed for a very specific use case. For example, generating iDigBio API calls like the one I showed earlier. And it's really easy to actually make these kind of small scope agents. All you have to do is tell the LLM how it should behave. So for example, you give it the instructions, you translate user requests into iDigBio API calls. And from those instructions, you just assume it's going to give you URLs. And of course, it might not always do that. That's where the validator comes in. So the validator's purpose is to, now that we have an agent and we have a very predictable output format, or we want, we will know what we're expecting, we can see if we do get what we expect. So a validator for a URL would be, of course, make sure it's a URL, but we'd also want to make sure it points to the right API. We'd want to make sure that the search parameters that it's using are valid, that they are like Darwin core terms or whatever iDigBio is using in their APIs. And if it turns out that the agent's output is not well formed, then the validator tells the LLM to try again. It gives it a little feedback and guides it toward building a better response. And here's kind of a 1,000-foot view at what we implemented. So the first agent that we always use is called an orchestrator. And what this does is it takes the user's request and it identifies what the user wants and which agent should be used to fulfill the request. So the request is, I want all the records for this species, the polar bear. And the orchestrator decides, I'm going to choose the record finder agent, which is going to call an iDigBio API or generate a call to it. And then once we have that call, it's not a very nice natural language format for, it's not good for conversation. You don't just want to spit out a URL. So to present it nicely, we hand it off to this assistant agent, and that just turns it into a nice natural sounding text. So for example, there are this many records in iDigBio. You can download them here. That's much better than having a URL. So here is a demo of our thing that we implemented. So we say hello, it says hello back, very nice. And then we ask it, how many records does iDigBio have for species occurrences in Japan? We hit send, and it replies, and it says iDigBio has this many records for the species occurrences in Japan, so about 500,000. Now, when I click that button, what this is showing is what the agent outputted. So the raw outputs, they don't necessarily answer the question, but they give us the data that it got from the iDigBio record or API. So you see that what it got matched the number we got there. So we know that it's doing what we expected. Now we ask, what are the top 3 species by record counts? And then it goes back to the API and it finds the top 3 species. So in Japan, iDigBio has the most records for these 3 species. And then we say, show those records on a map for one of those species. And then a map appears, and there we go. We have all of the different occurrence records. Now, I think there's 2 more. So we ask it to show the URL it used to call the API to retrieve the records that it's showing on this map here. And like a good chatbot, it does that, and there's the URL that it used. So we're trying to facilitate transparency so that you always know exactly what the chatbot is doing. Because if you don't know what it's doing, it's hard to trust it, right? And then finally, we ask it, please send what it found to me at my email address. And then there it goes. It'll package the results as a Darwin Core archive and send them to my personal email. And then the cheeky little chatbot makes a mistake at the very end. It outputs some symbols that we can't yet process. So, and that's it for the demo. So going forward, we're not done with this thing. We have a lot of plans in the future. Specifically, if you play with it yourself, you'll find out it can break pretty easily if you do things that maybe isn't cooperating with. Then there's a lot more of the iDigBio APIs that we want to expose. We want to add more validators to make sure the outputs make sense all the time. And we want to incorporate information sources outside of iDigBio, such as like taxonomic checklists and different authorities that can supplement what's in iDigBio. And then finally, we want to add some form of inference, so getting information out of LLMs, which is kind of a dangerous road, but we want to do it with quantified confidence, so detecting when the LLMs are correct or incorrect about their inferences that they make from the data or from their own knowledge. And that's very broad. You can talk to me about that maybe another time. So that's it. Thanks for listening. If you want to play with the chatbot, there's a QR code and you can talk to it. I hope you don't break it, but if you do, let me know. And then finally, Manny did as much work on this as I did. So I just wanted to call him out. So you can ask questions to him too. So, all right, thank you very much.
Awesome. Thank you so much for that talk. And yeah, once again, I think you guys know the drill by now. Feel free to come ask questions.
No questions. No, wait, there is a question. But first is a comment from Alan Stenhouse. Says, yes, use the LLM as an agent and or UI as an interface to the APIs and ontologies, etc. And then he said, nice work.
Thank you.
Rukeya Joadine asked what LLM are you actually using?
Oh. Yeah, so we're using GPT-4o. That's the only one we've tried so far, and it worked well enough, but we do plan to try others.
And then Alan asked, were the results on the number of occurrences in Japan actually accurate?
They were accurate to what's in iDigBio. Now, that's not to say that the search necessarily got everything, because of differences in what's actually in the records, and people spell things differently and format things differently, so we can't do much about that, but it gives the same results that you would get if you built the query yourself, at least in most cases.
And then Rukeya has another question. Are you using their assistance API? Did you try function calling or structured outputs?
Yeah, so function calling is part of what we use to make sure that the outputs are what we expect. So for example, but we're kind of hacking the system. So with function calling, you specify a list of functions that the LLM can call, so things that it can do. It doesn't call them, though, it asks you to call them. But what we did is we made those function names the names of our agents. So it'll have functions such as search iDigBio for records, or count records, or generate a map, and all these different functions. And it thinks it's calling functions, but it's asking to call the next agent. So we are using the function calling for that.
Okay, and we're going to move on to some in-person questions. We'll start right here, and then we'll go here next, and then we'll move on.
Hi, my name is Lena Struve from Rutgers University. This is very interesting, and I would love to talk to you because I did one, or me and my colleague did one for using GBIF, a similar ChatGPT derived thing. And the problem is that when you download the results, you really need to check, you need to have a quality control, because you need to see which ones that have images, if there's mistakes, if there's things like this. So there's a direct link back to every single or observation, specimen, whatever, right?
Right.
Right. So I think that needs to be included in the chat as a kind of warning thing that says that this data set is given the data, but you yourself have to be responsible for testing, checking, making sure before you use it for further research or something like that.
Yes, definitely. Yes, I totally
Some
agree.
caveat thing.
Yes, exactly. And I think that's actually a great use case for these chatbots, because using like the portal search and everything, you don't really get these warnings. You have to go other places to learn about all the different caveats and nuances with running these searches. Whereas with a chatbot, if it detects that you're running certain types of searches, if it's instructed, or if it's well informed, it should be able to give you warnings, especially if the things you're finding do not match your intent.
Right, but the chatbot doesn't know what's right or wrong. It just reports whatever.
Right.
But anyway, so what I wanted to say also is that I gave a talk at the Botany Conference about AI and education. Okay. And I have a fact-checking example how to fact-check ChatGPT using resources. So students learn how to fact-check the results of any kind of botanical or organismal stuff coming back. So maybe we should talk about things like this, because I think we should join forces on this.
That sounds great. I would love that.
Thank you.
Thank you.
Awesome. And our next question.
Hi, I'm Nicole from Biodiversity Heritage Library Australia. Loved your talk this year and last year. Kind of left field question. You were extremely polite, and with both the chatbot and your working with ChatGPT. Greetings, hello, please, thank you. Just wondering why you're doing that. I get teased for doing the same. So.
Oh, that was more just for the humor of the demo. I don't do that when I'm using it by myself.
Okay, so you're not worried about chatbots taking over?
No, I don't think it's angry with me.
Thank you.
But I should say, if you do use the demo, I hope it's not too late for this. Anything that you type in there is getting saved to a log. It's not tied to you, but it is being logged. So Don't put your social security in there or anything.
Or do, I don't know.
Or do.
Anyways, thank you so much again for your talk, Michael. And we will have our next speaker, which is just me. So welcome me to the stage. Okay, hi everybody. Once again, I'm Kit. I'm a PhD student at the University of Colorado Boulder. I also work with iDigBio, and I'm an intern at the NASA Goddard Flight Space Center. And in this talk, I'll be talking about kind of a passion project that I started a couple of months ago and have been building on as I can. But it's a comparative method for building chatbots. I look at open source hybrid and fully integrated large language models. And I named it Charlie. I would love if anybody has any ideas how to turn that into like a super cool acronym, but I named it Charlie because this is mainly dealing with Darwin Core and Charles Darwin. So yeah, let's get into it. Okay, so I probably don't need to give too much of an overview of biodiversity informatics and TADWIG, but as we know, TADWIG is the Biodiversity Information Standards group. We used to be known as the Taxonomic Database Working Group and recently changed the name and kept the acronym because it is, I can't remember who said it, but somebody in TADWIG said that TADWIG is a little bit more sticky on the tongue. So what this is looking at is the Darwin Core Standard, which is a standard that is upkept in order to map terms to GBIF, so you're able to get data in there. One of the challenges, though, that I've seen people face is I've mainly been working in the ecology and remote sensing world as of late. And a lot of people are starting to use Darwin Core, which is really exciting. I was in a meeting at NASA the other day and someone was like, yeah, we usually use USDA codes, but I've just heard of this thing called Darwin Core, and I'd like to start mapping it to GBIF. And I was like, oh, hi, I'm Kit. Let me tell you more than you ever wanted to know about Darwin Core and TADWIG. But a lot of ecologists and remote sensing experts don't have me or don't have a TADWIG advocate in their group in order to kind of help them see the ropes and how to use Darwin Core. It's a very straightforward standard, but with all of the stuff that people already have on their plate to keep track of, with standards and aggregators, it's a lot to have to add something else in. So my objective was to create a tool that decreased mental load on researchers via an interactive platform for them to be able to ask about standards and ask about how to map their data to GBIF. So the first thing that I did, I was like, well, my background is software engineering at a SaaS or a software as a service company. And when ChatGPT came out and a lot of customers were just like, we want AI, the response was, let's slap a chatbot in every single application that we've ever made, which I think that chatbots really do have a place and they can be very helpful, but it is important to ask if that is the most, the most efficient use of resources. And on top of that, what type of chatbot is needed to accomplish the goal. So the first one that I looked at was trying to make a chatbot that used fully open source packages without a large language model. And then I looked at using fully open source with large language models. Next, I explored a hybrid approach, and then sort of like what Michael just talked about, directly integrating with the OpenAI API in order to create a fine-tuned model. My focus was to look at performance, how much it costs to create that, and time for both it to be created, and what is a kind of time prediction for how much upkeep will be needed for that model. So the sources that I used for this specifically is I looked at TADWIG documentation. So I have a web scraper available on GitHub. If you would like that, feel free to reach out to me, where you can scrape all the terms from Latimer Core, Darwin Core, and Audiovisual Core is what I have so far, and I'm adding in more standards as I go forward, and it puts all of them in the same format if you want to use them for training data. So my process was to systematically extract it through an HTML web scraper so I could have a lot of control how I was getting returns, and then noise reduction. So in addition to the terms, I also took GitHub issue tracker data and scraped that in order to put into my training data. However, there were a couple of them I think there was only like 56 in all, so it was a very manageable data set for me to go through and be like, I don't know if we should include this in training data, but scale is also a very important factor to think of. And my goal was to create a high quality data set because, as I just said, I didn't have a lot of data between GitHub issue tracker and between terms. It's like a fairly small data set in order to train a chatbot on. So I needed to have a really, really high quality one to kind of offset that issue. So method one, I used Spacey for one of my tests, and then NLTK, which is an open source Python package that you can download off of pip. It stands for Natural Language Toolkit. And I created a rules-based response and tokenization and tried to really focus on certain entities to recognize. And I also created a script to basically format it into a question response. I guess I'll just say format again, in order to make sure that the training data was consistent across everything that went in. This was extremely cost effective because it was free, and if it's free, take two. But it was also extremely quick to develop. However, it was really bad. It was very, very bad. It was such a small data set. There was not a lot for it to go off of. So it was really adequate for like very simple things where you're like, what is the Darwin core definition of species? And I was like, I can tell you that. And when you went a little bit past that, was like, how would I use this very specific term in this very specific way? It usually just gave me back really random definitions where it picked out words that were in that definition. So cheap, but not the best option. So the next thing that I did was use fully open source methods with large language models. And I used Hugging Face. I tried a couple of different models. This is still something that I'm iterating through, so I'm not going too much into details, but if you want to ask like specifically what models I've tried so far, please feel free to come and talk to me after the presentation. And then I fine-tuned the data set by annotating it. So this worked, but basically what I was trying to do is I took the data set the training data set that I created in the fully open source one, and I had the large language model train itself to make more questions that were similar to the key pair values that I already had with questions and answers. So I could basically make a bigger training data set, and that seemed to work very well from what I saw. It was a lot better, so much better than just the previous one on complex queries. It does take a little bit longer to develop, and you have to use higher resources. I'm very fortunate to where I have access to CPUs and GPUs on a high performance computer at my institution, but in terms of sustainability, if somebody else was like managing and maintaining this, that might not be the best option. So something to think about. So yeah, improved accuracy, but required careful management of resources, because on top of that, I had a script running for purposes of this every day to see if anything new was added to Darwin Core or anything new was added to the GitHub tracker. And then I would have it recreate the training set and retrain, which is not a very efficient way to do that, but that was kind of what I was working with. Okay, the third one is my favorite. It was a hybrid approach. I used OpenAI and I used Hugging Face, and I used the GPT API in order to generate all of my training data. So that was like a very low lift on mine. And then I said, make three, I believe it was three, make three questions similar to each question that you see and recreate answers that are similar to the answers that you see. So there's just a larger corpus of data for the algorithm to deal with. And it was extremely balanced performance. I fed that really large data set into a Hugging Face model, and it was very flexible to develop because it took a lot of time off of my plate. It also was higher cost, but when you're only using it to create training data sets, I think I was spending like $2 to $3 for fine tuning. So like in the grand scheme of things, even if I did that every day, that's still only about $700 a year to keep a piece of software running. And if you've ever used enterprise software, you like can't buy enterprise software for that much. So I thought it was Cool. Super strong performance in my limited experience and with very controlled costs. And then the final one that I did is I integrated it fully just so I was like, hey, ChatGPT, here's some data. Do what you want with it. Fine tune on it. Which can be scary, but if you haven't played around with the OpenAI API, you can now put cost embargoes on your training models. And I was like, once this hits 60, kick it out. It's done training. There's nothing else. I can't pay more than that. So this did have the best performance by a little bit more than the previous one with the hybrid approach, because it was also able to pull a lot from the internet and use sources that I wasn't using because I was just looking at the GitHub tracker issue and the actual terms. And it was higher cost. I think it cost me like $30 to like train this from end to end, which also at the end of the day isn't that much. So if you have, it's suitable for projects that don't have a lot of budget constraints. And if you have a much larger data set, that's your budget constraints are definitely something to think about, but overall very successful. So impressive performance, more expensive. And in conclusion, I know we're all shocked by this, but different methods have different trade-offs for using them. And takeaway, different methods suited for different project needs. Choose AI based on your goals. Like it is not just one general model, like just start throwing things in it and mix it up. You need to choose it based on the goal that you want. So you're spending less money, spending less time, and getting the results that you actually need. And then for future work, I'm doing a lot of user testing and refinement in the future. So I'm still going through these models, trying to make them a little bit better. I'm just one person and I'm not a taxonomist. So it would be really useful to me if people were interested in doing like a blind user test of these 4 different methods and seeing how they perform, or even if they're necessary, because maybe they're not. AI isn't the answer to everything, but it's cool to look at as an option. So yeah. Aiming to do testing in January 2025 when I wrap up one of my other projects in December. And if you're interested in that, please email or come find me. And I would like to thank the 2025 Program Committee so much. Rukeya, who is the co-organizer of the session, she is the person who really started these sessions last year, so it's awesome to get to do it again with her. Tim Robertson and John Wajorek, plus anybody who maintains the Darwin Core Standard. And thank you to all of the members of TADWIG who contribute to and use and help us extend Darwin Core. So, thank you. And I will now moderate myself. We have just a few minutes for questions. We will start with Nikki, and then we will go over to Laura.
Thanks. Yeah, I'm Nikki from Q. Really interested in what you said right at the start of the talk, and I thought it's perhaps a little bit sad that you felt that it was necessary for you to scrape data out of the repositories for Darwin Core. So, what recommendations do you have for standards developers that would make the kind of project that you describe here easier to do without that first step?
I honestly do not know. Well, actually, I do. If we kept like just a CSV file of all of the Darwin Core standards, like in the format that I scraped them in, and like updated those, which with the script that I have, we can just like make a cron job and update those and find a place to like download everything in a machine readable format. I think that would be super helpful. Does that answer your question? Cool. Okay, we'll go to Laura, and then Matt, you can come up next, and then we're done.
All right, 2 questions in the chat from Alan, and is the first one. Alan Stenhouse, did you try just adding the standard information as data for a RAG type approach to increase contextual information for each query rather than training your own models? And then there was an additional an API interface to standards.
So I haven't tried that yet. I would be interested in it. If you send me an email, I'd be really happy to talk more about that.
And then Rukea added, there's quite a lot of questions on the GBIF portal GitHub about how to use some Darwin Core terms. Also, there are some papers discussing the development of terms that could be used for this. And she added, I feel like an API interface would be overkill. Yeah.
Okay, Matt.
Hi, Matt from GBIF Secretariat. TADWIG does have a repository with all this information that Nikki referred to in CSV format. It's called rs.tadwig.org.
So I did try using that, and it didn't give me the information that I wanted to in like the format that I wanted. So I like scraped it in a very specific way that like broke things out so I could reformulate them into questions. But I did get to that a little bit earlier in the process and I haven't revisited it. So I should probably see if it does actually have the information that I need now.
It should do, because the website itself is generated from that information.
Oh, cool.
So
yeah.
I have a note now that it's not well documented
Okay.
how that will work.
No worries. Awesome. Well, thank you so much for listening to me. We have our next speaker, Roselyn. Okay, you're here. Good. We have Roselyn Gabud coming up, and thank you so much for your attention, and thank you for coming up, Roselyn.
All right. Good morning, everyone. I'm Roselyn Gabud. I'm from the University of the Philippines, and I'm here to present the work of our students, Angela Shannon Tan and Paul Michael Demiuga. Our research is entitled Automated Knowledge Graph Generation in Biodiversity Research, Leveraging Machine Learning Tools and Techniques. One of the critical aspects of biodiversity research is the acquisition, organization, and utilization of biodiversity information. So if you're a biologist working on gathering data from literature, from journals, so we know that this is also a tedious task. There is a huge volume of studies, journals, and databases on biodiversity that are currently publicly accessible. However, this information or data are in unstructured format, meaning these are in text format, like the journals, like conference papers and articles. So utilizing in order to effectively and efficiently utilize this huge volume of information, we need tools that automatically converts unstructured data into structured format, meaning structured that are machine readable and readily available for analysis. This is where natural language processing, or NLP, comes into play. Specifically for this study, we used information extraction, or IE techniques, to extract data and related data from unstructured biodiversity journals or literature. The significance of this study is that it enables effective use of vast, valuable biodiversity information. So information extraction, there are two critical subtasks under IE. These are named entity recognition, or NER, and relation extraction, or RE. Named entity recognition seeks to locate and classify named entities in text into predefined categories. For example, examples of these named entities are taxonomic names, geographic location, and temporal expression. While relation extraction identifies relationships between named entities, or we can say that RE extracts related named entities in a text. And then these two, NER and RE, form the foundation for the application. We created the knowledge graph. Knowledge graphs provide a concise visual summary of the data. It shows a visual representation of interdependencies between entities that can be easily queried and can easily be identified by just mere looking at it. So in this study, we used the BioDiv NERE corpora for our data set. This corpora was developed or created by Abdelmajid et al. It consists of two corpus. One is for NER, which is BioDiv NER, and one for RE. This data are constructed, this corpus were constructed from scientific metadata files and abstracts. It contains 10,000 annotations for NER, meaning it has it has labels for 10,000 named entities, like consisting of organisms and environment, location. And then it is composed also of 4,000 statements for relation extraction. So there are 4,000 related entities labeled in this corpus. The classes and relations were based from the Biodiv Onto. It's a biodiversity ontology which was developed by the same group as well. So in this figure, you can see the conceptual map of the named entities and relation types. You can see there is a named entity or type organism, which is maybe could be plant, animal, microorganism. There is environment, which is a natural or man-made environment where organisms live, phenomena, location, quality, and matter. For the relation types, we worked on 3 relation types. There is the have relation type, which could happen between an organism and environment. Organism have a quality, and then the second relation type is occur in. An example is organism occur in a location, an environment occur in location. There is also an influence relation type that may happen between an organism and phenomena. So an influence, for example, an organism influence a phenomena. So in this work, we fine-tuned several large language models. So we grouped them into 2. So we trained non-BERT-based models like Electra, FNet, and MPNet. We also trained BERT-based models like BERT, DistilBERT, and Roberta. And the 7th LLM is the BioDivBERT. It's a BERT-based model that was pre-trained using biodiversity-related corpus. So for the NER, the BioDivBERT showed the best performance for named entity recognition. And then for the relation extraction, despite being trained only on general domain, the BERT model performed better than the BioDivBERT. This is the application pipeline that we've implemented. This is the NER, RE, and application pipeline. You can see on the image on the left is a sample sentence from a paragraph. That sentence is fed into the NER model. And then the NER model extracts or identifies the named entities, like in this example, that's plant, nitrogen, phosphorus, and soil. These named entities are fed into the RE model, the relation extraction model. So the RE model determines whether a relationship occurs between two named entities, like, for example, nitrogen and soil, and it categorizes what relationship type occurs between these two. For the application, we develop the tech stack for the application we developed. For the front end, we used HTML, CSS, JavaScript, and D3.js. For the back end, we used Flask. There are 3 significant features for this application. One is the automatic graph generation from user inputted text. So the sample sentence on the left is converted automatically to a knowledge graph that you can see on the rightmost part. The second one is there is a filtering options for entity category or relation types, and there is graph zooming and panning feature as well. Now I'm going to show you some screenshots on how to use the we call it BiodiVis, so a biodiversity text graph generator. On the left part, you can input, you can upload a text or PDF document, or you can also, or you can also paste raw text on the right part. And then when you click submit, it will generate this type of knowledge graph. These circles or bubbles are the named entities that are extracted from the text that you inputted. And then the lines are the relationships. So there is a full view of the knowledge graph. So as you can see from text, we can automatically generate interconnected named entities. There is also there showing you the filtering. You can choose which entities, named entities to show. For example, here we choose environment, phenomena, location, and then you can also select which relation type you want to display. When you have applied the filter, there you can see this graph. So the contribution of our work is that it showcased the effectiveness of fine-tuning NER and RE models for biodiversity research, and for named entity recognition, we show that BirD performed the best for named entities, and then for RE, despite being pre-trained only on general domain data, BirD performed better by 3% in terms of F1 score compared to BirD. And then we demonstrated integration of these models to automatically generate knowledge graphs from text. I'd like to thank our lab, the Computer Vision and Machine Intelligence group, and thank you for your attention. Thank you to Tadwick also.
Awesome, thank you so much. So we definitely have time for questions, and also the final 15 minutes is discussion. So if people want to bring up questions that they had previously, we're welcome to do that. But yeah, any questions for this talk?
So it was really interesting, and I was wondering, how do you check for the name recognition and relation extraction if it is true or not? Is it like manually annotated at some point?
Yes, the data, the corpus, it was manually labeled.
Okay,
that's what we use for training.
All right.
And then a separate data set, a portion of that was used for testing.
Okay, thanks.
Any other questions so far? Okay, yeah, come on.
Hello, my name is Martin from the BD Biodiversity Museum in Canada. This is a question for everybody that is using ChatGPT or LLMs as an integration into their applications. How can we prevent the use of ChatGPT 4.0 API tokens for general purpose use by people on the web? So for example, there's a car dealership that had a ChatGPT 4 integration, and people discovered that they're just handing out free ChatGPT 4 tokens through this interface and can use it for general questions. Has anybody come up with a way to kind of avoid that problem or limit the scope of what the API can do? Just for the demo that was just presented for the Tadwood, if you asked it a question, tell it to write you a Python script, it'll do it because it's a general purpose LLM. Yeah.
So I think the way to, I haven't had much experience with that because I have just been testing it myself, but I think the answer to that would be using fine-tuned models that are to focus on the specific issue at hand, which you can do through GPT-4. Unless somebody else knows something I don't. And we have a question online. A comment online.
Rukeya said, haha, this is a fun one. I don't think anyone has, but you could have a gatekeeper agent maybe. Like the one who fields questions and then discards anyone who says, can't see the rest. One moment, please. Like the one who fields questions and then discards anyone who says something non-related. Anything, I mean not anyone.
Awesome. Thank you so much. Let's give another hand for Roselyn. Okay, so we do have like 10 to 15 minutes for just general discussion. We did this last year and there were quite a few things that popped up. That being said, I know it's super early in the morning, so there will be a discussion session after each of these. But if anybody would like to raise any questions online or in person or discussion points, please feel free to come up to the mics. And I will just be here staring. Oh, I don't have to. Thank you.
Hi, I'm Rod Page. I have a question, I guess, about the iDigBio example. So you said ChatGPT got the API wrong, the URL wrong, because it said api.iDigBio. My question is, maybe it got it right in a sense, because that's a very common way of expressing the URL. So it's another way of thinking about it. If ChatGPT says this is what it should be, might that be a useful suggestion? And related to that is, if I used your chatbot, how easy would it be to port to GBIF? And if it's tricky, why are those APIs different, if that makes sense?
Okay, so I'll address the second one first. So I'm actually not super familiar with the GBIF APIs. I've never used them myself. I would imagine there's sort of a correspondence. You can map one to the other. And I imagine that you could do that with a script. So you wouldn't necessarily need to incorporate the LLM. So in that case, you might be able to just take what our LLMs are outputting and just map it directly to GBIF. I'm not sure if that's the case. I know there's going to be caveats like with iDigBio indexing things differently and keeping a little bit different data, so it's not going to work across the board. But I don't imagine it would be super hard to transfer. Everything that we're doing, like we haven't, everything we do is defined in the instructions that we just verbally give to the LLMs. Like we're not doing fine tuning or anything. So all you would really have to do is change the instructions and tell it which fields are different and why. And I'm sorry, I am slipping on the first question.
So ChatGPT suggested it should be API.
Yes, yeah. Yeah, I mean, it's good and bad, right? Like it might be a good suggestion. I personally don't really have any responsibility for the iDigBio infrastructure as it is right now. So I don't know, but I can see it as maybe a good design tool. Like maybe even if you're asking about like a new tool you want to develop, you might say, how would you use this tool? And it can kind of give you the general intuition that somebody might have. I think that might be a great way to sort of drive design of new services. It's probably too late at this point to change things, right? But at the same time, it's a little bit concerning because when the LLMs generalize information from other systems to a system that you're using, those generalizations might not always be correct. Like there might be nuances that are different and they should be different for your specific system. So you never quite know if it's just, it thinks it knows, if it's making really good guesses, or if it actually knows your system. And that is why with our work, we tried to avoid as much as possible having the LLM draw on its own knowledge and purely use it for natural language processing. So we give it all of the information it needs to use our systems rather than expecting it to know.
more comments from the chat, I believe related to this conversation. Alan says, I'm working with multi-agent systems a little, so you can perhaps get around this by having tools for agents that do web search along with a bunch of other tools and agents, i.e. it should be able to find the actual API site or documentation and find out what APIs are available.
I'm just going to keep doing this until somebody else speaks. I was confused by the question about the car companies and the ChatGPT. So was that the idea that you can set up a chatbot and people can come along completely different area and just sort of use it and basically use your tokens? Is that?
Yeah.
Yeah, the question and one of the responses about having the orchestrator kind of decide where to put that query in terms of the different bots that have different responsibilities is to try to alleviate the case in which users discover that it is just hooked up into a ChatGPT 4.0 token, which costs a non-trivial amount of money for people to use. So if they discover a free one on the web, they can be likely to say, well, why would I pay for my ChatGPT-4 subscription when I can just use this bot that exists on the web? So early on in the ChatGPT development, there's a car company that had just a customer service bot hooked up, and people discovered that it was just broad in scope, and you could have it do anything that the ChatGPT-4 service was doing. And then they used that for free as opposed to their own tokens, and it wrapped up a huge bill for the car company because it wasn't restricted. So yeah, just as people have been using this, I'm very curious how they go about both making the bot useful enough and broad enough in its range to answer queries without giving it broad enough latitude that people view it as, well, here's a public service. It's going to be not tied to any billing if it's at a museum or a GBIF. And to alleviate that case of people just saying, I don't need to pay for my own tokens, I can run it through this. Yeah, I hope that clarifies.
Super quick follow-up. So one example I have seen is where people have put demos online and you have to provide your own key. So the idea is this is going to work great. I'm not paying for it, which obviously has implications for like people just trying it. But one approach is bring your own key, stick it in, and away we go.
Are you saying that like you see people do demos where they show their key in the demo?
No, there's one early example. It basically took a guy called Paul Graham. He had a really cool blog about running startups. Somebody has scraped his blog, stuck it online, and said, here's a box where you paste in your key. Nobody else can see it. It's a bit like an API key that we use, say, for GBIF, and I guess iDigBio is the same thing. So you have to have a key to play. So if I did that, I would have the expense. So you'd avoid somebody else ransacking you. I guess the flip side is that's, people are going to get a key and get up credit card stuff, and it might sort of be a slight hassle in that sense.
Cool, thank you.
Rukeya wanted to add that she still thinks having a gatekeeper agent that decides if this question is real or relevant for this bot is the best way to go for this, and she thinks she read a paper about it somewhere. And Alan says you can and should set limits on your billing.
It's a great feature.
I want to share a case about our works. I'm doing maybe the same work in Taipei, and we create a chatbot to overcome the language gap because we found that LLM can translate English to every language, so it's very useful in Asia, like us in Taiwan. And I can share you a point like, there's no need, like we always need to use OpenAI API. We can choose to like install Olama list tool, and it can install nearly every open source LLM like Gemini or other or Llama 3.1 that will be useful. So they will be free, maybe free, like or cheaper than OpenAI's API key. Thank you.
Thank you. That's really useful, actually.
Alan has added, you can also run models locally and use APIs to access them. Llama 3.1 is good for many purposes. And then he added, exactly.
I'd say exactly to that too. We've tried running that locally. That's really useful. I wanted to say, coming back to the first talk from Pat about carbon costs and environmental impacts, Hugging Face, which Kit also mentioned in her talk, has got a really nice documentation about how you document the carbon costs of the model that you produce, and it might be something that we think about as a community to recommend that we do that if we're building models for biodiversity, that we think about the costs involved and properly surface those costs.
Yeah, I've never really thought about that, but that would be like a really transparent way to show like what type of computing power we're using.
Yep.
I think that is something we should be working on.
Yeah. So Hugging Face, they kind of pioneered the model card and dataset card interface on where you are browsing datasets and models, and they're using that kind of idea with carbon costs too. Yeah.
We have time for like a couple more points, or I can let you guys get tea 4 minutes early. You're all adults, you can make your own decisions, but feel free to come up if you have a couple more points, but I release you if you do not want to come up. Thank you, everybody. This was great. And our next session is after the tea break, and then we'll have lunch after that, and then the final session is at 2:30 p.m. local time.
これ早かった今。タイムの